Okay, so now we're going into section 4.2. Again, this chapter 4 is about trigonometry. So in section 4.2, we want to make sure we learn or review, whichever it is, the trigonometric functions, and talk about this thing called the unit circle, as many people like to talk about. Okay, so use a unit circle, etc., etc. Make sure you read through the learning objectives and understand exactly what we're trying to do with all of this stuff. And then here's the examples that we're going to go through to try and reinforce what's going on with all these ideas. So first of all, trig functions and the unit circle. Trig functions are actually defined by what is called the unit circle. The unit circle is a circle of radius 1. That's where the word unit comes from. So for example, this point 1, 0, right? The circle of radius 1 where the center is the origin, 0, 0. So every radius would have a length of 1. So the point 1, 0, the point 0, 1, the point minus 1, 0, and the point 0, minus 1 are certainly on there. Okay, trig functions are defined this way. Every point on the unit circle, which has coordinates x, y, is actually the cosine of theta and the sine of theta. So the x coordinate is cosine theta, the y coordinate is sine theta, and theta is the angle that is measured from the positive x-axis to that ray of the radius of the circle. Okay, so that's your angle. X would be the cosine of that angle, y would be the sine of that angle. That's how the trigonometric functions are defined. Okay, so you certainly should know, like this angle here, that's 0, right? That would mean that the cosine of 0 is 1, and the sine of 0 is 1. This angle for the positive y-axis would be pi over 2, or 90 degrees. That means that the cosine of 90 degrees, or the cosine of pi over 2, is 0. The sine of 90 degrees, or the sine of pi over 2, is 1. Over here, these are called the main quadrantal angles, by the way. Over here, the point minus 1, 0 is on there. So the cosine of what angle is that? Pi, right? Cosine of pi, or the cosine of 180 degrees, is minus 1. The sine of 180 degrees, or the sine of pi, is 0. Okay, so if I'm measuring from the positive x-axis, I'm coming all the way around. I've come around to 270 degrees, or 3 pi over 2. So the cosine of 3 pi over 2, or the cosine of 270 degrees, is 0. And the sine of 3 pi over 2, or the sine of 270 degrees, is minus 1. And then once I come all the way back around, I'm back to 2 pi, or 0. So the cosine of 0, the sine of 0 is the same as the cosine of 2 pi, or the sine of 2 pi. Okay, so those values are the same. Actually, we'll learn a lot about the periodicity of these functions later, but you can tell that they repeat. After I get to 2 pi, and then when I go from 2 pi to 4 pi, everything repeats. When I go from 4 pi to 6 pi, everything repeats. So cosine and sine are what we call 2 pi periodic. They repeat every 2 pi. Okay. So what I want you to know are these what are called famous 30, 60, 90 or 45, 45, 90 right triangles. Because knowing these and the relationships of the lengths of their side, you can find the value of the sine of theta and the cosine of theta of different angles, right? Not just these main quadrantal angles like 0, pi over 2, pi, and 3 pi over 2, but I want to know any angle that's in here. Well, you're not going to be able to know any angle. But what you should be able to know is any angle that's a multiple of 30 degrees, 45 degrees, or 90 degrees by understanding these triangles, right? The 30, 60, 90 has the ratio of its sides. If I say the hypotenuse is length 2, then the side opposite 30 would be length 1. The side opposite 60 would be length square root of 3. 30 degrees is also known as pi over 6. 60 degrees is also known as pi over 3. In the 45, 45, 90, if I label this 1 and 1 on the sides, then the hypotenuse would be square root of 2. So just have to remember these triangles and then use these as reference angles reference triangles, because then we remember this thing called SOHCAHTOA, which stands for sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Okay, so which means sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And then we also have 6 more trig functions. I'm giving you like a trig class in one little block here, right? when you first learn trig, all this stuff took a while to develop, but this is what I need you to know to be successful in Calc 1. We also need to know that the cosecant of theta is 1 over sine, the secant of theta is 1 over cosine of theta, and the cotangent of theta is 1 over tangent of theta. So that would mean that the cosecant of theta is hypotenuse or opposite. We don't memorize that. We just memorize these relationships. But we do memorize SOHCAHTOA to help us remember these guys. All right, try to see how to make sure you understand how to use those. All right, we also should know the even and odd properties. Basically, the cosine of theta is an even function, and then thus the secant of theta, because it's 1 over cosine, is also even. The other 4 of the 6 trig functions are odd. So they actually all have symmetry. The cosine and the secant, cosine of theta and the secant of theta functions are even, which means that they are symmetric with respect to the y-axis. And then the sine of theta and the cosecant and the tangent and the cotangent, these are all symmetric with respect to the origin. Okay, so for example, let's find the cosine of minus 11 pi over 6. Some people draw this entire unit circle with all the multiples of 30, 45, and 60 on them and label them and just want to use it that way. I would prefer, I can't force you being an online course, I would prefer if you understood those 30, 60, 90, and 45, 45, 90 right triangles and understood where you were and labeled the sides properly. So for example, cosine of minus 11 pi over 6. Now, minus 12 pi over 6 would be minus 2 pi. That would be, remember minus would be all the way around this way, right? Now notice since cosine is even, minus would be all the way around this way. Cosine is an even function, so the cosine of minus 11 pi over 6 is the same as the cosine of 11 pi over 6. You don't even have to remember that. You could have just figured out the cosine of minus 11 pi over 6 because that's the picture I drew. Cosine of minus 11 pi over 6. Actually, I drew the cosine of 11 pi over 6. I drew the cosine of 11 pi over 6, positive 11 pi over 6. If you had drawn negative 11 pi over 6, you would start here and go around almost 2 pi, but not. You'd be 30 degrees short. You'd be up here. But the cosine of those are the same. So how do I figure out how to label the sides of my reference triangle? Well, I know that when I come 11 pi over 6, I'm 1 pi over 6 short of 2 pi, which means I'm 30 degrees short of 2 pi. So this angle in here will be 30 degrees. So if that's 30, this is a right triangle, then that has to be 60. I label the sides. The hypotenuse is always 2. Side opposite 30 is 1. Side opposite 60 is root 3. However, I also have to remember, am I in the positive or the negative x and y directions? So root 3 stays positive because I'm on the positive x-axis. This becomes negative 1, though, because I'm on the negative y. I'm in the negative y direction. Then I just remember that cosine is adjacent over hypotenuse. So the cosine, I will use my reference angle. This is the angle right here, but the reference angle is this guy, is adjacent over hypotenuse, so root 3 over 2. Okay.